We are basically focusing on being just very good blockchain infrastructure that completely separates the validation layer from the execution layer. For the first time in blockchain history, you can plug in every Web2 application in JavaScript, in Python, in C#, in C++, directly into the blockchain. Your software application transforms into a decentralized software application that switches on Web3. We believe what needs to happen is deliver crazy scale without having to have heavy validator nodes.
I'm here with Melanie Mohr, co-founder of Powerchain. We're going to be talking today about how Powerchain is different from other L1s and how it enables projects to launch their own blockchains on this unified infrastructure. Before we get started though, make sure to subscribe, hit the like button, and hit the notification bell to get notified when new episodes drop every week. Hey Melanie, thanks for joining me.
Yeah, hey. So glad to be here with you. Thanks so much for inviting me over.
Yeah, of course. So we met in, I think, Abu Dhabi like a couple of months ago, and you were telling me about Powerchain, and you described it as a layer 0 blockchain. Now, I don't want to use that word to refer to like layer 0, the interoperability protocol, but that Powerchain was sort of a layer 0, that an underlying layer that sits underneath other L1s that can utilize different virtual machines, COSM, WASM, Move, SVM, EVM, or even other virtual machines that we're not familiar or not used to seeing in crypto, like the Linux VM and things like that. I thought this was really interesting, and we had a conversation that was sort of challenging this idea that it was a layer 0, that it's actually a layer 1. So I think we're going to get into that here. But before we do that, though, I'd love to hear a little bit about how you got into crypto, and also how did you start working on this problem?
Yeah. So I basically had a previous career in the media and marketing industry till about 2014, when I exited my media companies and pivoted into media and MarTech. So I started building mobile apps for content creation, content distribution. And in 2016, I discovered Bitcoin for myself. I thought, wow, someone has built this new financial system, completely decentralized and trustless. Was very fascinated by the underlying tech and dig deeper, and also put a little bit of my exit money into it. And then in 2017 saw Ethereum and all these amazing ICOs and business logic implemented. And so again, came a little bit more from an investment point of view. And then in 2018, 2019, I thought, I also would like to build in this space. And naturally, because of my marketing and media tech background, the first path went into SocialFi. So I had an idea around a protocol layer around word of mouth marketing and executed this, but it was really step by step. I would say I was very early in SocialFi. I integrated at the end this protocol layer in various apps and failed with one app where it was too early to introduce this new ecosystem and economy to basically people who are not crypto native yet. And then I brought it to more and more adoption over time. And actually at one moment in 2023, it was at around 200,000 daily transactions. And then I was looking into all the layer 1s and layer 2s and all the infrastructure out there and thinking, where could I migrate them over? Because most of the transactions were still in a centralized database. And this is where I got into the deepest Web3 depression after years in Web3, grinding hard, because I could not really find a fit for it. And then I met my co-founder, Eddie, in Dubai. He had a dev shop and was already a CTO for many years, and with 12 or sometimes 16 developers at hand. And I saw some other tech that he had built. And he told me then, Mel, I haven't told you yet, I have worked on this new blockchain and maybe you want to have a look. And well, at the end, I did more than having a look, and now I'm a co-founder. That's my journey.
Yeah, great. Okay, cool. And what's the current status of the project? Where are you guys on the roadmap?
Yeah, I mean, first of all, I would say what fascinated me about Powerchain, because to be honest, I was in 2023 in this deep Web3 depression where I thought, everyone who was coming with any blockchain idea, I thought, oh, why does the world need another blockchain? I was really so, I thought, this is not having a great future. I also did not see actually a super great future for interoperability because it is such a fragmented Web3 space. So it took some time for me to understand that what Eddie has envisioned and already started basically building and working on was so different to anything that I had seen in 8 years in Web3. And so where we are now, I mean, what I first of all liked when he introduced me to it, and I think, after we will dive a little bit deeper into what's really the solution and the problem we are solving here with. But what I liked about his attitude was he said, Mel, I'm a few months out of going testnet live. This was all bootstrapped so far. How about we bootstrap it together? And only in the moment we are going testnet live and show it to some founders and get some traction, we start showing it also to some maybe investors in your network. And I like this approach of, being so diligent and going more the legit approach. And that was also convincing me to join him in his journey.
Okay, cool. So let's talk about this solution, right? So there's different layers to this stack. People can check out the docs if they're interested. I'll leave a link in the show notes. But basically, the way you explained Powerchain to me was like a consensus layer, and that consensus layer allows transactions to be settled on this unified layer. And then there are applications, smart contract sort of execution layers that sit on top of it and settle to this layer. Now, to me, that sounds like sort of a shared security setting, right? Like a configuration where you have an L1 and then you have L2s on top of it. But you guys are intent on calling it a layer 0. Why you're intent on calling it a layer 0 and not just an L1 like everybody else? What makes you special, basically?
Yeah. So first of all, it is really the first infrastructure that completely separates the validation layer from the execution layer. So by doing so, we are basically focusing on being just very good blockchain infrastructure for consensus, the security, data storage, transaction record, and all of this with instant finality and with very, very high throughput and without having to compromise decentralization. And on top, you have the freedom to build for the very first time in any coding language and any framework. It's completely framework and coding language agnostic. So it doesn't have this framework like a Cosmos or Avalanche or Polkadot, where you need to use this framework to build your own layer ones on top. And very often you even have then to have still your own set of validators. In Powerchain's case, you have this layer 0 blockchain infrastructure you can build in Solidity with EVM kind of style virtual machines. You can build in Rust and Wasm or Solana virtual machine. You can build in Move with any sort of Move virtual machine on top. But, and that was the very convincing part for me, for the first time in blockchain history, you can plug in every Web2 application, Web2 software application in JavaScript, in Python, in C#, in C++, directly into the blockchain. And just basically your software application transform into a decentralized software application that switches on Web3. And I saw the developer adoption in Web3 already, I would say, as a huge failure, to be honest. 10 years after Ethereum, with a lot of money, billions that went into Web3 in investment, in grants, in hackathons. And from 28, nearly meanwhile 29 million developers on the planet, we have only migrated over to Web3 23,000. And so I was thinking, why? Why was no one more interested in blockchain and utilizing it? Or what was the hurdle? And for me, really, the hurdle is that we started with niche coding languages. Great for smart contracts, but with this focus, we also left many, many engineers, talent, creativity out of Web3.
Yeah, I have my opinions on this varies. I think most developers just don't see the use case. I think that blockchains, there's something that's a little bit understated in crypto, and that is that crypto is an exit from the fiat system and from the traditional finance system. A lot of people who build in crypto, I think, have this semi-quasi-political alignment. And there's something about crypto that is more than just building applications. That might be changing, and it certainly, I think, is changing in that direction with the things like NFTs and more kind of cultural applications. But I think that for the majority of people who are in crypto, there is this underlying political ideology that kind of comes along with it. And I think for most developers, they just want to like build an app and make a living and aren't concerned with exiting the traditional finance system as much as they may see problems with it, or the fact that it's fraught with corruption and fraud, et cetera, or all the other problems that come along with it. So I think that probably accounts for a lot of why developers are not making the jump into crypto. And the complexity of the development languages and how they are different from existing development languages, that to me feels like less of an issue. I mean, look, when mobile phones came out, right, like everybody was building in PHP, and then all of a sudden they had to learn like whatever C# or something to build like an iPhone app. That didn't stop millions of people from start building, mobile phone applications and other types of applications. I think crypto really has this chasm, which is, in order to be a crypto person, like you have to be a crypto person. And that I think counts for a lot.
I would say, yes and no. There is one thing. We started with blockchain infrastructure that was the last 10 years focused on smart contracts. And smart contracts are great. They obviously have brought something completely new to the world, having trustless business logic execution. Nevertheless, they are siloed. That's why Web3 is so far siloed from Web2. And smart contracts, which this was actually also something that I didn't know before really meeting Eddie and discussing things with him, was I didn't know that smart contracts can so far only utilize a handful of algorithms. And the thing is, if you would be able to code on a blockchain using existing coding languages like C#, JavaScript, Java, coding languages that have decades of computer science backing, and all of these beautiful algorithms, and algorithms are the ones that are running the planet, the digital planet. They are allowing us to do sophisticated things. And the beauty is, when you are now coming and allowing engineers to use their skill set and to use the algorithms that allows them to explore things and to be creative, that can bring blockchain to the totally next level. And this is what we have already seen when we introduced, for example, Powerchain to some first engineers. That was even before we did fundraising. Immediately, I would say it was nearly 24 hours later than when we came out, hey, you can code in Golang, here are the tools, and in JavaScript and Java, etc. One engineer immediately came and said, I have built a completely decentralized private key recovery system in Golang. And we said, how have you done that? And he said, yeah, because I was able to use algorithms that I wasn't able to use in the smart contract space. And that's just, what we have seen so far is with the ability to open it up, allow all the engineers out there to develop and be creative, they can come up with completely new use cases that we haven't seen in the last 10 years in the blockchain industry.
Yeah, interesting. There's this argument that there's 13 million JavaScript developers around the world. Like Agoric makes this argument that now we have JavaScript on chain. And so like those 13 million JavaScript developers can start building on blockchains. Newsflash, I don't think they're going to start building on blockchains for the reasons that I brought up earlier. But also I think, blockchain development languages, as bad as they might be, right, or as difficult as they might be to onboard, things like JavaScript, its vanilla form, are not great for building blockchain applications because of all this kind of runtime behaviors, et cetera, that are not great properties for a smart contract language, where you want things to be like to run very deterministically and to run in a very predictable way. Now, things like Rust, of course, have made its way into the ecosystem because it's formally verified, because it's like strongly typed, et cetera, and there's like very little room for error. But like, do we really want developers to start building applications using like languages that don't have the security considerations? I'm not an expert in this field, but I do know that like I write in JavaScript, and like it often throws things at me that I'm not expecting. And, a lot of people have sort of talked about JavaScript as really like being a bad idea for building blockchain applications? Yeah, how do you think?
I mean, I can just tell you now what kind of adoption we see because of this, opening up to all coding languages. And we have EVMs on top. We have teams building, on EVMs on top. So it's not that we are, not seeing also adoption in the Web3, traditional Web3 coding language style. Nevertheless, a good example is a big corporate out of India. They are kind of one of the media giants in India, 100 million subscribers. It's Shimaru Entertainment. They are kind of also the Netflix of India. And they had already for 1.5 years worked on a new metaverse entertainment platform, actually with smart contracts, with Solidity and smart contracts. And then they heard about us and they said, wow, we could theoretically really use your blockchain and use our JavaScript developers that we have in our office since 20, 30 years and that are trusted, that also know all our, business secrets, and really we trust them so much. They have actually worked together with an outsourced Solidity team on, the smart contracts of this new entertainment platform. And we said, yeah, I mean, you can try it out. We gave them all the tools and, the documentation. And in, I think it was about a week, after just a week, they came back and said, we have it already deployed. Our whole big entertainment platform that we have built for 1.5 years is already deployed on Powerchain with JavaScript. And then we looked into it, and I have to tell you, it looks amazing. And I was so far a little bit, I don't want to say skeptic about, metaverses, but we all, I would say similar to me, building in SocialFi for some years, we have not seen the adoption that we all wished for in the metaverse space. But their metaverse is actually one that I can see really working out. I mean, they are going to go with us basically mainnet or launching when we are going mainnet, but it is the first metaverse that works so beautifully on a mobile phone, for example, not only on a desktop. And it is completely built with JavaScript. And now they decided for now to not use smart contracts, but really to plug it into the blockchain directly. And it is amazing from the user experience.
So, okay, I want to come back to this later, but maybe let's talk about like the power base layer. And there's a few things you said earlier about how it doesn't compromise decentralization, et cetera. So I'm curious, like that base layer, can you describe how it works? What's the consensus mechanism? How many validators are there? And how is it interacting with those applications? Do you have like, for example, in the Cosmos SDK, we have this ABCI, right, which talks between the consensus layer and the application. So how are different applications, different VMs, whether kind of crypto VMs or non-crypto VMs, talking to that base layer?
Yeah. Still, I need to also say, overall, I'm not an engineer. Yeah, I'm not an engineer by background. I'm talking more from a high-level perspective. I would say after now 8 years in Web3, I have a good understanding of architecture. But nevertheless, in some, if we would really go deep, then definitely my co-founder, CTO, would be the better one to talk to. Nevertheless, I mean, let's break it up. It is basic. So we, as said, consider ourselves more as a layer 0 base layer blockchain on which you can build any other blockchain layer 1, but without them having to have validators. I mean, they have something that is a little bit, could be considered as some sort of more instances, of their own virtual machine. We call them conduit nodes. But overall, you have this base layer taking care of security, consensus. We have a signature algorithm that is quantum secure, or definitely capable and already also used in other blockchains or known for its quantum security, called Falcon. We also have developed an own one, proprietary one, that is also going to be implemented at a little bit later stage. So it's a base layer that is taking care of the validation and the security. And the consensus is a brother of Tendermint, but we call it Delegated Proof of Power. And the core difference is that all validators earn an equal share of the rewards. And then you have the delegators that are delegating to these validators. And let's assume, you have one validator with 500 delegators and one validator with 100 delegators. naturally the one with 100 will earn a little bit higher yield in the beginning because all share the same rewards, all validators, right? So, but what we believe what will happen, and we have already tested it and have kind of seen it, there is an equilibrium after obviously mainnet and a few weeks or a few days or a few months, an equilibrium between all of these validator nodes. We have a set amount of validators. So we start with 200. We will slowly increase to 400 and maybe later even to more. But it's a set amount of validators. Nevertheless, because of the equilibrium, it is, I would argue, in some cases more decentralized than the pure proof of stake mechanism, because what we have seen, I think also even in Ethereum, is that some validators accumulate a lot of voting power, a lot of staking power, and you could say also they are getting more powerful within the system. So you can then argue how decentralized the system really is. And in our case, we believe that the math behind will create this equilibrium, and with a Tendermint approach of a 2/3 that you need to overthrow the system, that it is very, very secure.
Okay, so the consensus algorithm relies on validators. Those validators have somewhat of an equal voting power, or at least their rewards are shared in a more equal fashion. Does this practically affect their voting power, and what's the threshold? I'm just curious about this consensus mechanism and like how it's really different from Tendermint.
Well, it is. I mean, what Eddie has tried here is in some ways to improve it also, to make it more scalable. And that's also a reason why we, for example, decided on not using elliptic curve as a signature algorithm, because it is also computationally heavy, and using something that is more lightweight. But overall, I mean, the big difference is this adjustment of allowing or generating this equal share and the equal possibility to propose blocks and also to share the reward between all of these validators. Now, how much is the threshold? I mean, we will see, especially through the delegators, how big the participation will be. But on a good note is the costs to run the network. And that was also very important for our team to build a blockchain that is super lightweight. So to run the whole network, one validator node costs, I would say, between $4 to $5 a month, up to, let's say, in a maximum, likely $60 a month. Yeah. If you compare this to Ethereum, I think there we are around $250, $300 a month. And if you look into Solana, it's a couple of $1,000 a month. And if you look into Aptos and Sui, I mean, all the blockchains, the newer blockchains that are currently out there, they have heavy machines in place for validator nodes. And because the blockchain here is not doing the execution, it doesn't have a virtual machine itself. It's not intertwined with a blockchain in the sense of like Ethereum or Solana. Therefore, there's a very, very lightweight blockchain. And the validation of the whole blockchain network costs, compared to Solana, for example, like one Solana validator node a year. And therefore, you need to think, okay, how much does a validator, for example, also need to make per year, in money to make it worth their effort and time and to secure the network? And this is our goal to show that a blockchain can run at scale, but actually with very, very low hardware.
Okay, yeah, interesting. And so let's now move up the stack.
Okay.
So like how do applications interact with the Power base layer?
So now you have basically the virtual machine. We call them also VIDA layer. And on this virtual machine layer, have they can, again, be framework agnostic, can be EVM, Solana virtual machine, Move virtual machine, or a software application. And they plug into Powerchain. And on top of them, they have their own, for example, they can decide on their own gas fee model, transaction model. On Powerchain, we don't have gas fee. We only charge on the bits and bytes level as 0. I think it's now 60 or 501 cent. It's a very low amount of per transaction or per byte. And therefore, they have a good range in which they can make money by having their own gas fee model, their own coin for the gas fees. And then on top, you have all these different other applications also with their own coin model. And they basically have to pay the fees of the layer 1. But when they are sending a transaction, without the user really knowing that we are underneath, because for them, they use, for example, a Bitcoin sidechain, EVM-based Bitcoin sidechain that only uses Bitcoin for gas fees and transaction fees, for example, right? The user sends a transaction and without really knowing it, sends it directly to Powerchain where it gets settled and where then the dependent RPC node picks it up, or conduit node RPC node picks it up and gets it executed. So I would say for the user, we are an invisible blockchain infrastructure. They don't have to care about power and Powercoin. They don't have to have Powercoin. They only have the coin of whatever virtual machine they are using here. And that's kind of beautiful. So every layer 1 can completely keep its brand, focus on being a very good ecosystem to onboard amazing applications, and obviously innovate in the virtual machine space. That's basically what they should focus on. While we are their settlement layer and we are this unified truth layer for data storage, transaction record, and then the VIDAs basically, or this layer 1s, are having their own truth model and kind of a deterministic approach to figure out that both have the shared truth, the settlement layer and the execution layer.
Okay, and so these blockchains that sit on top of the Power base layer, they settle their own transactions. So does the settlement happen in their VM, or does it happen at the base layer?
At the base layer.
Okay. Why is it happening? I mean, why does the settlement need to happen at the base layer? Why couldn't it just happen at the application layer?
Because they don't have validator nodes. They are basically I know this is a little bit a different, it's so new. No one has done it yet this way. I would say our architecture mirrors a little bit more the internet architecture as this one communication layer, and you have infinite processing layers on top, and on top of them, the whole digital world. Similar to this, our architecture is basically the blockchain internet layer. And so they don't have to have validator nodes. We have the validator nodes. So they don't have even any operational costs. They can really focus on, and our operational costs are, as I told you, very, very low, right? 1 Solana validator node per year cost, kind of. And so they can just focus on being a very good execution layer, processing everything properly to their rules, whatever their rules are. But they don't need really to have the validators on their side. Everyone can run instances of their truth. Their truth is open source, stored also as basically their open source code is stored also on Powerchain. So you can see exactly the rules each layer 1 has to execute on top. And therefore there is this correlation between our truth of data and transaction record, their truth of how they execute, and then you can everyone can run an instance of their layer 1 truth.
Okay, and where is the data stored? So does Power base layer also provide data availability?
Yes, it's basically Power is a completely a data availability layer with infinity data availability. So if you compare it to Celestia or Avail, all these data availability layers, they are storing the data for a few weeks, maybe a month, but usually just a shorter period of time, while Powerchain is really storing the data till eternity.
Okay. I mean, so how do you then handle the bloat of the chain? I mean, if Powerchain becomes the base layer for, the majority of blockchains, let's say, then running those nodes would become quite expensive, right? I mean, how does that work?
Because we are not executing, it basically, it stays as lightweight as always, and it can execute. I mean, we have now this number, 300,000 TPS, but this means 300,000 basically with one, maximum 2 CPU core servers. And the more CPU we would add, or the validators would add, the more powerful it actually can be. And therefore, a 300,000 TPS, I would say, is possible. And we have already in testnet, obviously, tested it out with kind of ease. And that solves, scalability in some sense is obviously also solved now on some layer 2s or, in the Ethereum ecosystem, and also some newer layer 1s have crazy scale. But what we believe what needs to happen is deliver crazy scale without having to have heavy validator nodes. That's this is basically what we have, I think, now also seen with DeepSeek, right? That was the surprising moment for everyone in the AI segment, was how was it possible that someone was now able to run a large language model like DeepSeek on so little hardware? And if you look back into the whole history of tech innovations, it was always like this. Only in the moment we were delivering crazy quality increase, exponential quality increase, while decreasing the cost for something exponentially, like the mobile phone, right? The smartphone. In the beginning, super expensive. Now everyone can afford a $50 good smartphone that can do nearly everything, like a little mini computer in your hand. And this is when you get it also to scale and mass adoption. And that's what Power enables through its very lightweight blockchain infrastructure that doesn't care about the execution. Every layer 1 is completely separated. They are all their own instances, and layer 1 doesn't care what the other is doing. It can have interoperability between all of them naturally because they are connected through this one data truth on the base layer, and they can connect through so-called conduit nodes, but they have their own state. It's not like on, the problem on this connection of this one virtual machine with this one blockchain is if you execute one, let's say USDT trade, smart contract, everything has to be executed. And that's, making it so hard and hindering scalability. But here on this base layer, it's like the internet. You have on the internet, Amazon Web Service, Alibaba Cloud, Microsoft Azure. On top of them, you have the digital planet, and you can add so many servers, as many as you want. It will not hinder the internet in its scale. And that's basically the architecture that we went after.
So how is it different from restaking or other forms of shared security? Because like in those models, like in restaking, you have an AVS. That AVS does its own execution, and that gets secured or settled to an underlying chain, or at least like the state is secured by stake of an underlying chain. Is the difference here? Yeah. Maybe.
I mean, it's delegate. It's just DPoS. Yeah. Here you have still the delegators. Yeah, and you have definitely it is a blockchain. Yeah, so you have a block after the other. And I would say here, additionally, the advantage is we have instant finality. That was very important for us also to bring to Web3 with this blockchain solution. And therefore, everything is settled instantly. So there is no restaking in that case, needed.
Okay. So who's running the execution layer of the individual chains?
They run it basically, or not only they. I mean, you create your virtual machine, you plug it in, and then, there are, everyone can run instances of this and make sure, everyone who is also having maybe a software application on top who wants to definitely make sure that the execution is done properly can run an instance and basically see that the smart contracts are executed in the manner of this virtual machine. Right.
Okay. But then it's a little bit similar to Ethereum L2s then, I think, because it's like
without a sequencer. The thing about there is no sequencer.
Okay. So Powerchain is running the sequencer.
Well, there is no sequencer. I mean, in that case, we don't have that. We really have only the pure, data truth on Powerchain. At the end, a blockchain, or what you always need is, this one set of truths of data and transaction record, and the truth of the business logic, right? And that's basically, that is coming deterministically kind of together here. It's not always easy to find this one thing fits all answer, because actually it is more on Powerchain, because we were looking into scalability and into delivering this one trust layer for data storage and security, this unified layer. We wanted to keep it as open for everyone to create these virtual machines in the manner they want. They can, you can theoretically run it not as decentralized as if you don't need it, but you can upgrade your virtual machine in your way to make it as trustless, decentralized as you want. But for example, if you are a corporate, and for you it is more important to switch on Web3, you want to have immutable data storage, immutable, decentralized, always available data storage, then you can use it. But it's maybe not so important for you that, even on the execution layer, everything is so decentralized. So we leave it more up to the teams and to their use cases and to their needs to create as much additional, decentralization as possible. But from a data storage transaction record layer, our solution is completely decentralized, I would say, because of the delegated proof of power consensus.
Okay, so you're saying that the construction of Powerchain makes it such that it is suitable for applications that may need a sequencer or applications that may not need sequencing. So for example, if you're just running like some JavaScript application that's, I don't know, sorting to-do lists, right? Like it doesn't need a sequencer. The sequencing of transactions is not necessary and it's not crucial to the application. But if you're running a DeFi application, sequencing is very important because it will have an impact on which account balances get updated first or in which order. And so sorry, yeah. Go ahead.
Oh, no, please. Sorry.
So then what I'm saying is, like, because of this, individual applications or VMs can choose whether, like, what sequencing configuration they want. So I was reading your docs and it mentions something about conduit nodes providing some sequencing. Is that correct?
Again, depending on, what the different layer wants, what they want, but...
What they want, okay. So then applications can decide whether they need sequencing, and if they do, then they can implement, say, their own sequencer or utilize some of the infrastructure that's provided by the conduit nodes?
Yes, there is utmost flexibility here. Yeah, that makes it, I think, so interesting, we hope, It definitely, we were prioritizing the flexibility for everyone to do whatever they want and decide how much decentralization they need and how to set it. It puts a little bit, I have to admit, right, a little bit more, framework agnosticness, puts a little bit more work onto the ones who create their VIDA. We have now basically these layer ones. We have provided so far EVM layer ones also to teams that came to us. We said we have already, created a EVM-based layer one for, if you want one, we give you one for free. And so we have meanwhile 15 teams that took over some layer ones, some EVM-based layer ones on top. But it's usually, if you want to build a Move VM or a Solana virtual machine or whatever, a WASM-based one, then you can decide how decentralized, how you want to build it, with what sort of, sequencing, if you want it.
Okay, cool. And so but then, like, would you agree then that the VIDA, which is the verifiable immutable data application, so I guess these are like those blockchains that are built on Powerchain, then they start to look a little bit like L2s, right? Like if they're if the a VM is run, say, like off chain, right? It's being run off chain from the consensus layer, from the Powerchain consensus layer. And then maybe they're running their own sequencer. To me, it starts looking like an L2, unless I'm missing something.
Because you don't need a sequencer, it's at the end really not needed. And therefore, and we don't have any sequencer inside, everything is ordered, basically what comes in there is in the time. And therefore it's not, in our case, it's not there. And it's also not needed to be decentralized completely.
Right. Okay. So let's just talk about this token a little bit and the utility of the Power coin. What's the role of the token? And like, I guess also, how are applications, right? So like if you have an application, say like some DeFi application or a DEX or like some layer one, I guess you want to call it, that is using Powerchain. Like, do they have to hold Power token in their application to be able to pay for use of the chain?
No, basically it happens a little bit all under the hood. So there is because Powerchain also uses a new signature algorithm. We need to wrap things to make it really possible to be settled on Powerchain. Yeah. And let's say you use an EVM, on top, then it goes from the project, the app that you're using, the transaction goes paying basically in their crypto, the transaction and gas fee, and then it gets directly through a conduit node where it gets prepared to be settled on Powerchain. And these conduit nodes basically have Power token. Yeah. And so on the one hand, it's needed by the conduit nodes. On the other hand, obviously by the validators. On the other hand, by the delegators for then governance and voting. And for the ecosystem. Also, you need to pay when you're developing or when you're creating a VIDA, your layer one, basically, you also have to create a VIDA ID. And this needs to be paid also in Power.
Okay. Cool. This has been really helpful. I'm still grappling with the idea that how these are not just L2s, but I guess it's just a question of semantics. But yeah, if people want to learn more about Powerchain, they should read the white paper. The V2 white paper actually just came out like a couple of hours ago as we're recording this.
Yes. And we tried actually to now with this new white paper, because this is always the semantics, are on the one hand, when you're catering to the Web3 world, right, we have our semantics around it, even when you call something a layer one, then everyone thinks a layer one is a layer one with own validators, So, and then we figured out to also cater to the Web2 developer community and to corporates, etc. We need really to create our own semantics in some sense, And that's why we have now the new white paper that tries to bridge it, to make it super easy to understand for all the Web2 developers and engineers out there, still trying to explain the new semantics also to the Web3 developers. And I definitely encourage everyone to give it a read. I think it's quite interesting. New way describing tech.
Any interesting or sort of exciting things that are on the roadmap that people should be looking out for?
Yeah, I mean, we are hardcore shipping towards mainnet. And so far, I mean, fingers crossed, how it sometimes is with tech. And we have seen many big infrastructure plays also postponing a little bit mainnet here and there. In our case, we plan to go somehow maybe end of Q2, beginning Q3, mainnet live, and still have to have a TGE before that. Exciting things are now that we have great builders. We have, for example, an amazing team also out of the Telegram Ton community that has taken over a Ton EVM. And their experience was basically that there are so many great game developers and amazing, also social products and projects that are already building in the Telegram realm. But they like Ton to use it also in this ecosystem, the coin, but they would prefer to deploy their projects on a Ton EVM. And so this team decided to cater to this. And so they have a Ton EVM with already amazing projects and adoption in their ecosystem. We have a high-level team of crazy big brains, PhDs from South Korea that have a Bitcoin sidechain on top of Power. Then we have also, I would say, a team that is building a little bit kind of a gala system approach for the gaming industry as their own VIDA and layer 1 on top of Power. And as I said, we see great corporate adoption, like Shimaru Entertainment, that they have already deployed this big new entertainment platform. And with them already having 200 million subscribers, I would say the chances of this new entertainment platform with exclusive content, with obviously also a metaverse where you can purchase land and NFTs and you can watch exclusive content in a digital cinema all together. They have very interesting features, I would say, in their metaverse. And this will be the first metaverse also on a mobile phone. So this is great to see that there are big corporates already deploying. We also have a corporate here out of the UAE, like a SAP, kind of a software as a service company, but they have 7,000 clients. And they have invoicing and loyalty points and healthcare data storage, etc., where they are working with our technology. And yeah, it's good to see that. Yeah, big corporates are already adopting it. And besides the Web3 space, yeah.
Okay, excellent. Well, Melanie, thanks for coming on the podcast and telling me more, breaking my brain about Powerchain. And look forward to learning more about it and seeing it go live.
Yeah, soon. And I also have to say we have amazing backers. Yeah, I mean, this was also very important for us, to get some really good, and Tim Draper and Draper VC and Magnus Capital and Alphabet and Red Beard Ventures, to name just a few, and Amazing Angels. So we were very lucky to get some good backers already on board. But we are exploring, this is the last, thing now, how to move on now with funding. And we have looked into the potential of going the public crowdfunding route. And I think after what we have seen in our space with Hyperliquid and also all these amazing AI agents and virtuals and AI 16C and also all the meme coins in last year, that there is a wish, I would say, for REIT to come in early again. And we are currently exploring this as our way to do a TGE. Very excited about this. And we have innovated something very cool. We will introduce it soon to the Web3 space. I think everyone is thinking about ICO 2.0, how this could look like, and how we can invent it in a new and solid and sustainable way. Tokenomics, etc. Working on something that we are very excited about.
Thank you.
Thank you.